In this problem, we're asked to obtain information about a function from its graph, and we're actually asked to obtain several different things about this graph. The particular question here is focused on part F. So all I've done is enlarge that graph, and I do want to focus on two things actually, parts E and F, because they kind of go hand in hand. So let's first look at part E. For what values of x is f of x equal to 0? Well, those are the values or the places on the graph where the function is touching the x-axis. In other words, its y-coordinates are 0. And that's these 3 points that you see circled here. What we list are the x values. The question's asking for that, and that's a very common thing to do when we're asked, where is the function equal to 0? List the actual x values. So we would list the -6, -1, and 4. Now what that does is it kind of places a division by boundaries on this function, where we see part of the function is above the x-axis and the other part is below. So here's another common question, what you see in part F. For what values of x is f of x greater than 0? What that's really saying is, where is the function greater than 0? Where is the function positive? Or where is the function above the x-axis? So now what you see here highlighted in yellow are those regions where the function is greater than 0. You could also say where the function is positive and where the function is above the x-axis. If you look at the specific y values, you even see that those y values of those points are all positive numbers. Like the first one to the far left is 0. Well, that's not positive, but that's going to create our boundary, right? And then we have 6 next, and then 4. We have another boundary here of 0. And then look into that other rightmost piece, the y value there of 4 is listed. And we can safely assume that everything else in these shaded regions are also contain positive y values. Now what we list as the answer are the x values of these intervals. So this is why the problem really hinges on what you answer for part E, because you need those zeros of the function as those boundaries. So all I've included here is that interval notation to say that I want to include all the x values between -6 and -1, but not including those endpoints, -6 and -1. You are asked, however, in the problem to write that as a compound inequality, so that's why you see for the inequality marks, they're not using equal to signs underneath those inequalities. The only difference for this next boundary is we can include one of those endpoints. So you see I've written that interval notation here on the x-axis itself. I don't want to include the 0 at 4, but I can include the endpoint 6. So I'm using that square bracket. And again, since I'm asked to write this as an inequality, not as interval notation, I would just need to be careful to express that square bracket with the less than or equal to symbol that you see in the compound inequality in this answer. So that's how we find the two intervals where the function is greater than 0 or positive or above the x-axis.